So, hello guys, hope you all doing great and your academics well. So now we are going to discuss about hash functions, so which is used in cryptography subject, and also it is called as a backbone for cryptography. So we all know that cryptography is basically used for securing process which is used encryption and decryption algorithm for secure any applications and data. So let me see the hash function under cryptography. So what is mean by hash function? So hash function is basically a one-way transformation taking an input and producing a unique output of a fixed value. Coming to input and output part, so input can be any size while output is a fixed length. Your input can be any size. It will allow any size of your input and it will produce as the concise output. Guys, please listen. Your input can be any size and it will provide your concise output. This is called as hash functions. So the next type is deterministic. It has the deterministic hash functions. Let me see the definition. So basically deterministic meaning that the same input will always provides the same output. So when you are provide the larger input, it will provide the hash value in a larger manner. So this is the very example for deterministic hash functions. Let me enter into the properties. So basically it has the three ideal hash function properties. One is pre-imaging resistance, second one is second pre-imaging resistance, and third one is collision resistance. So pre-image resistance, so it is computationally infeasible to find the original input from its hash value. So it couldn't be find the original exact input for your hash values. So the second one is, so it is very difficult to find different input that produces the same hash value.
So basically, what is meant by different input? Your input can be any format and also any size. It doesn't consider. It will do a mathematical operation and also provide the same hash values for every calculation. So this is called second pre-imaging resistant. And third one is collision resistant. So it is computationally infeasible to find two distinct inputs that produces the same hash values. Yeah, it also has the challenges which cannot be find the two distinct input which provides the same hash value. So these are all the properties of ideal hash function. So let me see the next slide. So basically there are four common hash function algorithm. So first two is MDS and SHA1. So which is not a pure secure algorithms because it also some insecurities when you are using these algorithms when comparative to 3 and 4. So basically 3 is SHA256 and 4 is SHA512. So this is the more secure hash function algorithm commonly used in blockchain technology and digital signatures and etc. And it is also a robust hash function which has a larger output size, offering even a higher security. So these two main algorithms were used in everywhere and also provide security. So these are all the main and common hash function algorithm. So let's see the next slide. So working of hash function, which has these three main stages. First one is input processing. Your input can be first divide to a fixed size blocks, and the second one is mathematical operations. It can be do a mathematical actions which is correctly fixed to your input, and then it will provide the correct output. Your output can be a fixed length hash values. It often represented as a hexadecimal string. Let's see the effects. There are two main effects, which is collision effect and avalanche effect. So collisions means two distinct input might produce the same hash value through it high improbable in well designed hash functions. And the second avalanche effect is a small change in input should result in a significant change in hash values, making it difficult to manipulate data and generating collision initially. So these are all the effects which will occur in while you are using the hash functions.
Next slide is applications. So what are all the applications of hash functions? So mainly it will concentrate in your secure applications or secure web pages as like banking and other sectors. So it has four main applications, which is digital signatures and password storage, blockchain technology, data integrating, and image processing, and also etc. So many applications are having hash functions. And then coming to conclusion. So conclusion, it is a fundamental tool and also used in diverse applications and continuous evolution, or will be in hash functions. So these are all about hash function in these cryptography subjects. Thank you.